Hello everyone, this is Shubham Chaudhary and I welcome you again in the new video of our YouTube channel. So today we will be discussing this LeetCode medium problem, even odd tree. So today is 29th of February and let's discuss this problem. So a binary tree is named even odd if it meets the following conditions. So the root of the binary tree is at level index 0 and its children are at level index 1. Their children are at level index 2. So for every even indexed level, all nodes at the level have odd integer values in strictly increasing order from left to right. And for every odd indexed level, all nodes at the level have even integer values in strictly decreasing order from left to right. So we have given the root of the binary tree and we need to return true if the binary tree is even odd, otherwise return false. So in the first example, so this is the root array and this is the binary representation of this array, binary tree representation. So here the node value on each level are level 0 we have 1, level 1 we have 10 and 4, level 2 we have 3, 7, 9 and level 3 we have 12, 8, 6 and 2. Here we can see that level 0 is a even level and it has odd value, then level 1 is odd level and it has all the nodes have even values. Then level 2 is even and values are odd, and level 3 is odd and values are even. So since level 0 and 2 are all and increasing and level 1 and 3 are all even and decreasing, the tree is even odd, so we will return true here. Same for this example. This is the root array and this is the binary tree representation. So the node on level 0 it is a odd value, on level 1 which is a odd level have all the even values, and level 2 has all the odd values. So node values in level 2 must be in strictly increasing order, so the true tree is not even odd. So here level 2 we can see that it is not following the strictly increasing order, so we will return false because 3 is not strictly increasing. Then in the example level 3, this is the representation. So here node values in the level 1 should be even integers. So here level 1 is odd level and we have 9 and 1 as odd values, so it will contradict the conditions, so we will return false here. So let's discuss what will be the approach for this problem. So first of all, we will initialize the queue to perform a level order traversal of the binary tree. Here we will traverse the tree in level by level. So then we will start from the root node and incubate in the queue and maintain a variable to keep track of the current level. And then we will iterate through each level of the tree using a loop, and for each level we will iterate through all nodes in that level. So for each level we will iterate through that level and we will check what is the uh, what are the conditions, are conditions matching or not. So in the for each level in we will pop the front node from the queue, then we will check if the current node's value follows the given conditions based on the level, and then for even levels we will ensure that the node's value is odd and is strictly greater than the previous node's value, and we will ensure that, and then for odd levels we will ensure that the node's value is even and strictly less than the previous value, and if any condition is violated then we will return false immediately. After that we will update the previous node's value with the current node's value, and then we will enqueue the left and right children of the current node if they exist, and if the traversal completes without any violations we will return true, indicating that the tree is an even odd tree. So we can say that it is an even odd tree. So this is the approach. Let's code for the solution. Before that, if you are new to the channel, hit the like button and subscribe for more content. So first of all, we will check if root is null or not. So if root is null, then we will return true. Then we will create a queue of tree node. Let's call it as queue, and then we will create a level variable. Let's assign it 0 value. Then we will push root node to queue, and we will implement a while loop. So while queue is not empty, the loop will iterate. So first of all, we will calculate the size by performing this function queue.size. Then we will calculate the previous value because we want previous value, and then we will say that level modulo 2 equals to 0. If it is 0, then we can say that numeric limits of int is to minimum, or numeric limits int maximum. So after that, here we will implement a for loop from I equals to 0 to I less than size, and we can say that the first let's create a tree node, star node, and assign it queue.front. Then pop out the queue. After that, we will check if level modulo 2 equals to 0 and node value modulo 2 equals to 0, or node value is less than equal to previous value. If this is true, or we will check level modulo 2 equals to 1 and node value modulo 2 equals to 1, or node value greater than equal to previous value. If it is true, then we can say that we will return false. If any condition in this returns true, then we can say we will return false, and after that we will update previous value further. So previous value equals to, we will give node value to it, and we will add children to the queue. If node left is true, then we will push queue dot push node left, or we can say that if node left is not null, then we can add, and if node right is not null, then we will add push into the queue this node right, and at last we will increment level one by one, and we will return true. If nothing returns here, we will return here true, which states that our tree is even odd tree. So let's check the solution. This solution is based on this approach. So for more clarity, go through the approach and as well as the code parallelly. Node value. So it is wrong. Why is this? I think some syntax error is there. Q. Yeah, there was a problem in this syntax. So just correct it and let's check again. I have corrected the syntax for if statement and it is giving me right answer. Let's check for the hidden test cases. So the answer is right. So talking about the time complexity, here we are iterating through every node. So we are visiting every node. So the time complexity will be big O of n, where n is the number of nodes, and the space complexity will be big O of w, because we are using this queue and it is storing the w is the width of the binary tree, maximum width. So a queue, so the final storage will be the maximum width, so therefore the space complexity will be big O of w. So that's it. If you enjoyed the video or found it helpful, don't forget to hit the like button and subscribe for more content. And stay tuned for upcoming LeetCode problem of the day videos and exciting monster web development projects. Thank you.